Hi friends, today we are going to discuss about balancing of redox reactions by using half reaction method. So let's identify oxidation and reduction half reactions from the given reaction. Fe2 plus changes its oxidation state from Fe2 plus to plus 3, which is oxidation as because oxidation number is increasing. Cr2O7, chromium is in plus 7 oxidation state which changes to Cr3 plus. So as the oxidation state decreases, it is a reduction. So wherever oxidation state increases is oxidation and oxidation state decreases is reduction. Now let's write oxidation half and reduction half separately, which is a step number 1. Oxidation half is Fe2 plus gives Fe3 plus. But a reduction half is Cr2O7 2 minus gives Cr3 plus. So we separate it. Now in the second step, we have to balance all the atoms except oxygen and hydrogen. But in oxidation half there is no oxygen and hydrogen, so we don't need to do anything as it is. But reduction half, you see there are 2 chromium atoms in the left side, but there is no chromium in the right side. So we'll do the balancing like this. Cr2O7 2 minus gives 2 Cr3 plus. So now chromium is balanced. Now in step number 3, we have to balance oxygen atom. But there is no oxygen atom in the oxidation half, so there is no change in that. But in reduction half, you see, there are 7 oxygen atom. To balance 7 oxygen atom, the method is we need to put equal number of water molecules in the opposite side. Opposite side is the right side. We are adding 7 water. So now oxygen is balanced. Next step is to balance hydrogen atom. We need to add H plus ions in the opposite side. But there is no hydrogen atom in oxidation half, so there is no change in that reaction. But in reduction half, you see 7H2. It represents 14 water, 14 H plus, 14 hydrogen atom. So that 14 H plus to be added in the reduction half LHS. Cr2O7 2 minus plus 14 H plus gives 2 Cr3 plus 7H2. So we balanced all the atoms. Now the last step is we have to balance the charges. In order to balance the charges, we need to take the total count of charges in LHS and RHS. Let's take oxidation half first. Here Fe2 plus. So the charge of Fe2 plus is plus 2. So let's write the charge under that. Here I am writing Fe2 plus charge is plus 2 and Fe3 plus charge is plus 3. So how to calculate the number of electrons? We need to take the difference between these two charges, which is 1. It means 1 electron to be added in more positively charged side. So the answer becomes Fe2 plus gives Fe3 plus 1 electron. So in reduction half, let's calculate the charge. For each species, I am calculating Cr2O7 2 minus is minus 2, 14 H plus is plus 14. First to take the total, which is plus 12 in LHS. RHS, it is plus 6. Why? Because 2 into 3 plus, which is plus 6. And 7 water is 0. So the total charge is plus 6 in the RHS. Now the difference between plus 12 and plus 6 is 6. So 6 electrons to be added in more positively charged side, which is LHS. So I'm writing that reaction, which is Cr2O7 2 minus plus 14 H plus 6 electrons gives 2 Cr3 plus 7 H2. So now all the electrons are balanced. I mean all charges are balanced. Now finally we need to make sure that the number of electrons in oxidation half and reduction halves are equal. But in this reaction, oxidation half is 1 electron and reduction half is 6 electrons. To make the electrons balanced, we can multiply oxidation half with plus 6. So it becomes 6Fe2 plus gives 6Fe3 plus 6 electrons. And we don't need to do anything in reduction half. Why? Because it's already 6 electrons. So we balanced all the reactions and finally we write the overall reaction by adding LHS and LHS of oxidation and reduction. Similarly RHS and RHS of oxidation and reduction, which is Fe 2 plus Cr2O7 2 minus plus 14H plus. These are the LHS in oxidation half and reduction half. And while we are adding, 6 electrons will be cancelled, equal to or gives 6 Fe3 plus 2 Cr3 plus 7H2. This is the RHS of both oxidation and reduction half. So this is how we are balancing redox reaction in acidic medium by using half reaction method. Thank you all.